दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, we have discussed last class what is oxidation number and derived the oxidation number of different elements and discussed the characteristics of oxidation number. So oxidation number is a charge, an atom of an element appears to have in its state of combination, assuming that all the valences are ionic. So assuming that all the other atoms are bonded to that atom by ionic linkage, we will calculate the charge on the atom of the element, and that charge will be its oxidation number. So it explains the state of combination of the atom of element, to what extent the oxidation or reduction done to the atom to bring to that state of chemical combination. And now we will now compare the valency and oxidation number. Valency and oxidation number, they are two different things, but they are closely related to each other. They are two different. When you come to the valency, if we say the first point, if you come to valency is the combining capacity of the atom of an element. Combining capacity of the atom of an element, which explains the number of atoms of hydrogen can combine with one atom of the element. So now when you come to the oxidation number, the oxidation number is a charge an atom appears to have in its state of combination, in state of chemical combination, is the oxidation number. Then what is the relationship between them? Valency explains the combining capacity. How many atoms of this element can combine with, or how many atoms of hydrogen can combine with one atom of the element. That explains the combining capacity of the atom of the element, and there the valency of hydrogen is taken is 1. Or we can take the number of atoms of oxygen that can combine with one atom of the element. That also we can compare and say. But when you come to the oxidation number, it explains the state of chemical combination. How much of the combining capacity the atom of the element has utilized during the chemical combination. When it, suppose nitrogen has the combining capacity valency 3 or 5, but when you come to the oxidation number, we have seen it combines with the hydrogen to form NH3 ammonia. It combines the hydrogen to form hydrazine. It combines with the hydrogen and oxygen together to form hydroxylamine. So that means from the 3 or from the 5, how much of its combining capacity is used. So that is the relationship between valency and oxidation number. Second point is valency is a number. It is a number which explains the combining capacity. Now when it is a question of number, it does not have any charge, it does not have any sign. When you say valency is a number, it does not have any sign. It is neither positive nor negative, because the combining capacity, it has to combine, and it will combine. How much chemical combination will take place? Now it doesn't have any sign, but valency is a charge. When you are defining the oxidation number is a charge. means it may be positive or it may be negative. Or that means what? Positive, it has used when it is undergoing oxidation and taking part in chemical combination, or it is undergoing reduction to take part in chemical combination. So this is the way valency does not have any sign, whereas oxidation number always may be positive or may be negative. Then third, so valency is a definite property. It is a definite for a particular element. For example, carbon, the valency is 2 or valency is 4. Carbon monoxide, carbon dioxide. And always carbon combines the hydrogen, utilizes its valency 4. If you come to methane, you have C, carbon is bonded to 4 hydrogen atoms covalently and forms methane. If you come to ethane, C2H6, same tetravalency. If you come to ethylene, carbon is tetravalent. If you come to acetylene, carbon is tetravalent. Evidently carbon is tetravalent. But the moment you come to the here, in this case, it is not definite, it is indefinite. It is a large spectrum. For example, last class I gave an example. When you come to the one simple example I gave you, that methane, it forms methane, it forms methyl chloride, it forms methylene chloride, it forms chloroform, it forms carbon tetrachloride. So in methane, the valency of hydrogen is +1. So the carbon is -4. And here it is -1 +3. So it is -2. You can calculate plus. So when you come to it is 0. And when you come here is -3 + 1, it is +2 and it is +4. If you see here, so the carbon, so it can be in a state, it can be 0. In a compound also, the oxidation number is 0. But in every compound, and the atom of one element, using its combining capacity, the valency, and accordingly the formula we are written. We are writing the formula methylene chloride, but the valency becomes, it can be -2, -4, 0, +2, +4. Similarly, if you come to nitrogen, it can be +1, +2, +3, +4, +5, -3, -5. There also you can have 0. So this is the thing. So it is indefinite. It is not a variable. So one need not confuse the variable valency. Variable valency is different thing. But valency is always a definite. But whereas when you come to the oxidation number, it is indefinite, because it is using to how much of its combining capacity the atom of the element has utilized to come to that state of combination. The next point, the valency can never be a fraction, but oxidation number can be a fraction. Valency, why the valency cannot be a fraction? The valency can never be fraction. Why cannot be fraction? The definition itself explains. Valency is the combining capacity of the atom of an element, which explains the number of atoms of hydrogen can combine with one atom of the element. And since the atom cannot be subdivided, half a hydrogen atom cannot combine, or 1/4 of hydrogen atom cannot combine. So valency is never a fraction. It is a definite number. But oxidation number can be a fraction. It can be a fraction. We have seen in case of FeO, ferrous oxide, +2. Iron oxidation number is +2. Fe2O3, iron oxidation number is +3. But Fe3O4, it is +8/5. So there it comes a very variable valency. Fe3O4, if you calculate, Fe3O4, if we calculate, it is x. So 3x -8 we have Fe3O4. So 3x minus 8 is equal to 0. So x is 8 plus 8 by 3. So it's a fraction. If you come to Na2S4O6, sodium tetrathionate. Na2S4O6, sodium tetrathionate. So here sodium is plus 2, sulfur we are calculating. So plus 4x, oxygen minus 2, so 12 is equal to 0. So 4x is equal to 10. So x is plus 8 by 5. So here the oxidation number becomes a fraction. So this is the way there is a gulf of difference between oxidation number and valency. Though they appear to be same, but what is the relationship? Now valency explains the combining capacity, whereas oxidation number explains the state of chemical combination. That is the relationship between the oxidation number and valency. And using this oxidation number, the significance is it is explaining us whether the oxidation has taken place or a reduction has taken place to bring to that atom to chemical combination. So we can calculate by taking the standard values we have calculated, and in a compound also, for example, nickel carbonyl. I gave an example yesterday, the nickel carbonyl, NiCO4. Nickel carbonyl is a complex compound. Here the oxidation number of nickel is 0. Oxidation number of nickel is 0. It is though carbon monoxide, it's not carbonyl group. We call this a carbonyl, nickel carbonyl. And where you come to this in an amalgam, if you come to sodium amalgam, means when you take an alloy of sodium and mercury, the oxidation number of sodium is 0 and oxidation number of mercury is 0, because both are in atomic state. Neither sodium is oxidized nor mercury is reduced, nor mercury is oxidized, sodium is reduced. Both are in the elementary state. We melt them and mix them, then they form one thing, the alloy. So in an alloy is a mixture of two metals. It's not a compound of two metals, it is a mixture of two metals, and where they are mixed in molten state. If in the alloy one of the element is mercury, or one of the metal is mercury, then the alloy is called amalgam. Zinc amalgam, the oxidation number of zinc is 0. So but this is the thing happens in case of oxidation number and valency. So with these are the things I have just recapitulated what I have taught to you in my last class, and wanted to compare between oxidation number and valency. Now we are coming to today's class. We will discuss the second part of oxidation reduction. The oxidation reduction I will be teaching you in 3 parts. One part I taught you yesterday, oxidation, reduction, what is oxidation, what is reduction, then what is oxidation number, calculation of oxidation number, and the significance of oxidation number. Now we will be devoting this class what is oxidizing agent, then reducing agent, then what are redox reactions. Then next class we will discuss about balancing equations, redox reactions by ion electron method. So now comes what is oxidizing agent. So what do you mean by the word agent? Agent is the one is called as an agent when it is employed for a purpose. Secret agent, the people who are employed to collect the secrecy, then they are called secret agent. Sales agent, a company appoints people to promote its sales agent. Marketing agent, people are used to market their product, they are a marketing agent. So here oxidizing agent means a substance which is employed to bring out oxidation. if you understand like this, then there will not be any difficulty for you to what is oxidizing agent and speculate about oxidizing agent. If you say oxidizing agent, there is no vibration in you. The moment you say something, if you understand the meaning if you mean, then you can easily explain yourself, express yourself properly. So one is employed for a purpose. Means what? The one is doing a job. The one is performing a job and he is the agent. So oxidizing agent, the one which is used to bring out oxidation. What is oxidation? Addition of oxygen, removal of hydrogen, increase of positive valency, decrease of negative valency, addition of electronegative element, or a reaction in which loss of electron take place. So any substance which will bring out any one of such reactions, it will add oxygen or remove hydrogen or add an electronegative element or allow to increase the positive valency or allow to decrease the negative valency or accelerate the process of loss of electron, we will call that as an oxidizing agent. So once you know this, then you can write your own definition. You can write your own. Then what you say? Oxidizing agent is defined. Oxidizing agent is defined as the one which brings out oxidation, and get reduced during the process. We will define the oxidizing agent, the substance which brings out oxidation, and gets reduced during the process is called an oxidizing agent. So suppose we have a substance A. And we are oxidizing this. So oxidizing this means what? It will form AO, a compound, addition of oxygen, or removal of hydrogen, or it has increased its positive valency, decreased its negative valency, anything it happens. So that substance, who does it? Oxidizing agent will do it. So this oxidizing agent is bringing out oxidation. So then this O added to this will come from where? From the oxidizing agent. Where from the O will come? The O will come from the chemical substance used. That means, what will I say now? Oxidizing agent is one which can contribute nascent oxygen. Or in other words, the substances which are source of nascent oxygen are very good oxidizing agent. Then question comes, then why the substance which brings out oxidation and why gets reduced? Why I am using the word gets reduced? The oxidizing agent is giving this oxygen comes from where? From the oxidizing agent. Then oxidizing agent has lost the oxygen. Oxidizing agent lost this oxygen. So the oxygen has come out from where? From the oxidizing agent. The oxygen has come out from where? From the oxidizing agent. That means oxidizing agent is losing oxygen, or the oxygen is removed from the oxidizing agent. So removal of oxygen is reduction, hence gets reduced. Children, understand the meaning of the words you are using in the definitions. And once you read and pronounce just like Janagana Manadhinayaka Jai, no use. What you are telling national anthem, then automatically you will come to stand at position, your vibration will come, the tricolor will fly in your face, and your mind will go to salute your country and the country persons who are responsible for giving us the independence. So many things comes to the vibration in our mind when you sing our national anthem. So we feel deeply emotionally involved. We enjoy it. We respect our nation. We respect our tricolor, the national flag. We also respect the countryman who has sacrificed their life, dedicated themselves for the cause of independence of our country. So, but if you do not know that, you are thinking that you are singing a song, then there is no use of national anthem. Exactly, chemistry or physics or mathematics, if you understand each word you are using, then you will not be remembering anything and you will not be feeling any burden on you, no stress on you. So oxidizing agent is one which brings out oxidation. How it will bring out oxidation? What is oxidation? The loss of addition of oxygen. So oxygen will come out from that one. So this oxidizing agent must be capable of oxygen, giving oxygen. Then gets reduced. Why reduced? Now because the oxidizing agent is losing oxygen, that oxygen goes to bring out the oxidation. So oxidizing agent loss oxygen, or oxygen is removed from the oxidizing agent. So removal of oxygen is reduction, hence it got reduced. During the process is called an oxidizing agent. Then what more? What more? Oxidation, removal of hydrogen. Removal of hydrogen means what? Then what is it? Who will remove the hydrogen? Who will remove the hydrogen? What is hydrogen? A positive one. What is hydrogen? Electropositive element. Then who will remove it? Electronegative element. Electronegative element. If you have also electronegative elements, they will be used an oxidizing agent. Who are the electronegative element after oxygen? The chlorine, bromine, iodine are more electronegative elements are present in 7th group of the periodic table. So automatically there is no oxygen. There is no oxygen. They cannot give oxygen, but are oxidizing agent. Why? Now because they can remove the hydrogen. And if they come, they are negative. So they will increase the positive valency. They will increase the positive valency. So if you analyze this, then examples you can remember yourself, and the explanation you can give. So who are oxidizing agents? So then example, what are the examples we can give? Now, one, substances which are source of nascent oxygen, which are source of nascent oxygen. They can give nascent oxygen, so they are very good oxidizing agents. They are very good oxidizing agents. So who will give? That who is rich, he will give. Or those which are surplus, they will give. So those substances which can give easily, they can give easily, contribute easily, they are oxidizing agents. One such example we can take as potassium permanganate. Potassium permanganate is an oxidizing agent. Why? Now because here the potassium, manganese and oxygen. Potassium is a metal, electropositive. Manganese is a metal, electropositive, and oxygen is highly electronegative. So potassium oxygen, it will form potassium oxide. MnO will form MnO and it will give us oxygen. So 2 potassium, 2K, 2 Mn, 2 MnO and 8 oxygen, so 5O. So a molecule of potassium permanganate is capable of producing 5 oxygen atoms in acid medium. So if a substance which can be oxidized comes nearer to potassium permanganate, we make the medium acidic and carry out the reaction. Similarly, potassium dichromate. We can say potassium dichromate K2Cr2O7 is also can give us nascent oxygen. How? We have potassium, we have chromium, we have oxygen. Potassium chromium will form potassium oxide, and chromium oxygen will form Cr2O3, and the rest of oxygen will come out. So we have 7O, so here 3O. So it can give us 3 nascent oxygen atoms, one molecule of potassium dichromate can give us this. Then question comes, why? Now because here manganese, if you calculate the oxidation number of manganese, the oxidation number of manganese is here +7, and manganese is placed in group 7 of the periodic table. It is in highest oxidation state. For example, you take a chalk and throw the chalk to the sky, it will go to a level. After going to the level, it will have a tendency to come down. To what? To come to the ground level. Similarly, manganese in atomic state, it is 0. Its oxidation number is 0. So when it is formed potassium permanganate, it has gone to which state? +7. Highest state is gone. From highest state can come to +6, it come to +4, it come to +2, it come to 0. So it has a tendency to come down. While coming down, it can go on decreasing its valence state and losing oxygen. So in acid medium, it gives 5 oxygen. In neutral medium, it will give us 3 oxygen. In alkaline medium, it will give us 3 oxygen, and neutral medium, it will give us 1 oxygen. If the medium is acidic, then it will donate 5 oxygen. If the medium is alkaline, it will donate 3 oxygen. If the medium is neutral, it will give 1 oxygen atom. So in all medium, neutral medium, alkaline medium, and acid medium, potassium permanganate is a very good oxidizing agent. Now if you come to the potassium dichromate, if you calculate the oxidation number, what is the oxidation number? +6. And what is the oxidation number here? +3. And here what is the oxidation? +2. See, from potassium permanganate, manganese is in +7 state and goes to which state? +2 state. So 5 units of the charge, the positive charge is decreasing. So it is highly oxidizing. Very strong oxidizing agent. Can bring out oxidation in many reactions. We are using potassium permanganate. Exactly here it was +6 state. Chromium is +6 state and comes to which state? +3 state. Hence it is this very good 3 units of decrease of 3 units of positive valence state takes place. So this comes. Now we can take sulfuric acid, H2SO4, concentrated sulfuric acid is a very good oxidizing agent. We have seen while balancing chemical equations by partial equation method, I have taken the example of constant sulfuric acid with potassium bromide, constant sulfuric acid with copper, constant sulfuric acid with potassium iodide. I have done many reactions, carbon, I have done boron, nitrogen, phosphorus, iodine. So many reagents I have taken and allowed the reaction to constant sulfuric acid to take place. So there this concept I have used, there I was using the word valence state. I am using now the oxidation state. So now come to this. So what are these? Hydrogen, sulfur, oxygen. Hydrogen, oxygen will combine to form water. Sulfur, oxygen will combine to form sulfur dioxide, and oxygen will come out. It will produce an nascent oxygen, constant sulfuric acid. So the moment you add to any nonmetal, all nonmetals have strong tendency to absorb oxygen, to accept oxygen. So any constant sulfuric acid, if they come in touch with constant sulfuric acid, they immediately react. Similarly, the metals have a strong tendency to displace hydrogen. The moment they come to touch with the constant sulfuric acid will give the nascent hydrogen. Then it will come. Then the second step, the constant sulfuric acid will decompose to produce oxygen, and the reaction will take place. Copper, you have taken the example. So it will give you oxygen. That the constant sulfuric acid is a very strong oxidizing agent. Similarly, concentrated nitric acid is also an oxidizing agent. Constant nitric acid is also an oxidizing agent. How? Now we have used the reactions you have done. We have hydrogen, nitrogen, oxygen. Hydrogen, oxygen, they combine to form water. Nitrogen, oxygen, they combine to form nitrogen dioxide, and oxygen will come out. So, 2 hydrogen, 2 HNO3, so 2 NO2 and O. So moderately concentrated nitric acid is also an oxidizing agent. So it decomposes to form water plus nitric oxide plus oxygen. And dilute nitric acid is also a very good oxidizing agent. So nitric acid in all concentration is a very good oxidizing agent, and this forms N2 and 4O. So we will say that concerned nitric acid, moderately concerned nitric acid, dilute nitric acid, they are very good oxidizing agent. So from the why? Now because in all these cases, what is the oxidation number of nitrogen? Here nitrogen is in +5 state. In nitric acid, the oxidation number of nitrogen is what? +5. Here +5 +5. So in this case, what is the oxidation number? +4. In this case, oxidation number is +2. In this state, oxidation number is +1. It comes from +5 state, so it is getting reduced. Decrease of oxidation number, reduction. See the definition. Oxidizing agent is one, brings out oxidation, will give you oxygen to bring out and gets reduced. Nitric acid becomes nitrogen dioxide or nitric oxide or nitrous oxide. That concerned sulfuric acid becomes sulfur dioxide. It is getting reduced. Why it is sulfur is in +6 state, and here in sulfur dioxide it is +4 state. So this is the definition. The definition I wrote, I am explaining, you are understanding from the reaction it is taking place. So these substances which are source of nascent oxygen are capable of contributing nascent oxygen during chemical reaction are used as very strong oxidizing agents. So the substances which are capable of contributing nascent oxygen during chemical reaction can be used as a very good oxidizing agent. Second point, removal of hydrogen. Who will remove hydrogen? So all electronegative elements are oxidizing agents. They are oxidizing agents. Who are they? Chlorine is a strong oxidizing agent. Chlorine is a strong oxidizing agent. Bromine is a strong oxidizing agent. Iodine gas, they are a strong oxidizing agent. If you come to fluorine atom, this is also oxidizing. Chlorine atom, bromine atom, iodine atom, they are strong. They can remove hydrogen. If you have any compound, add chlorine to that, it will remove hydrogen from that. Because they have strong electronegativity of hydrogen is 2.1. Whereas electronegativity of fluorine is 4, chlorine is 3, bromine is 2.8, and iodine is 2.5. Electronegativity is this. Negativity of fluorine is 4, chlorine is 3, bromine is 2.8, and iodine is 2.5. And hydrogen is 2.1. So hydrogen is positive in consideration to fluorine, chlorine, bromine, iodine. Hence they easily remove hydrogen. Hydrogen will have a strong tendency to go to fluorine, to go to chlorine, to go to bromine, and to go to iodine. And so they can be used to remove them. So they are very good oxidizing agents. Similarly, some chemical compounds where the elements have their higher oxidation state, they have the ability to bring out oxidation. They bring out oxidation. So, for example, one simple example I am giving you, sulfur dioxide is used as an oxidizing agent, but not always. So, its behavior changes. There are some substances, I will be giving the example, sulfur dioxide is a reducing agent, sulfur dioxide is also oxidizing agent. I will be coming to that, very soon I am coming to that, next step. So, this is what is oxidizing agent. Then third, so if you come to electron concept of oxidizing agent, we will come to electron concept of, according to electron concept, what is this? So what is happening? What is oxidation? Loss of electron is oxidation. Oxidation is a process during which the electron is lost. Oxidation is a process during electron is lost. So suppose you have an element M and it will lose electron. and then it will form M plus, the electron is lost. So what is happened? It is 0. It is 0. Valence, its oxidation number is 0. It's oxidation plus 1. So positive valency has increased. So this reaction is what? This reaction is oxidation. So who will do it? Now oxidizing agent. Who will do it? Oxidizing agent. This oxidizing agent will carry out the oxidation of M to M plus. So this electron lost, who will take? Oxidizing agent. Oxidation is a process which involves loss of electron. This is oxidation. Oxidizing agent brings out oxidation. So the electron lost will be taken by whom? Will be taken by whom? By the oxidizing agent. So oxidizing agent is one who can accept electron. So all electron acceptors are very good oxidizing agents. All electron acceptors, they have the ability to accept electron. That means those substances which are electron deficient, they are electron deficient, they act as oxidizing agents. They have the capability of bringing out oxidation. All electron deficient substances are also very good oxidizing agents. So according to electron concept, what will be our oxidizing agent? The oxidizing oxidation is a process. Oxidation is a process which involves loss of electron. Which involves loss of electron. So the oxidizing agent is one which can accept the electron lost during oxidation. So during oxidation, electron is lost, and oxidation is done by whom? By the oxidizing agent. So those substances which are capable of accepting the electron lost are called this. So this oxidizing agent is accepting electron, and addition of electron is called what? Addition of electron is called reduction. So the substance, the oxidizing agent, brings out oxidation and gets reduced. So we can now say the substances which can, oxidizing agent brings out oxidation. Oxidation is a loss of electron. So the electron lost is accepted by whom? By the oxidizing agent. So the oxidizing agent is accepting electron. So the electron is added to oxidizing agent. So oxidizing agent will be reduced. That's the reason oxidizing agent is one which brings out oxidation and gets reduced. So who are? So all electronegative elements, fluorine, chlorine, bromine, iodine, they have what? They have 7 electrons in their outermost cell. They have 7 electrons. For example, fluorine. Fluorine has 7 electrons in its outermost cell. So it has a strong tendency to accept electron. So it can accept electron and form F minus. Now fluorine, hence fluorine is a oxidizing agent. Fluorine is an oxidizing agent. Chlorine is an oxidizing agent. Bromine is an oxidizing and iodine oxidizing. Now you can say nascent oxygen is a very good oxidizing agent. Why nascent oxygen is oxidizing agent? Because oxygen has 6 electrons. Has 6 electrons with it. Atoms of every element have a strong tendency to accept electron to attain octet in their outermost cell. So the oxygen can accept 2 electrons and form what? O minus 2. It can attain octet by having 8 electron and minus 2. So that is the reason nascent oxygen is an oxidizing agent. Question may come to you. One mark question. Those of you who are appearing CBSE, ICSE exam, the question may come, nascent oxygen is an oxidizing agent. Then a student gets confused. Addition of oxygen is oxidation. Sure, addition of oxygen. So no, Oxygen has 6 electrons in its outermost shell, highly electronegative and very high electron affinity, so can easily accept 2 electrons, and hence those substances which can accept electron loss during the process are very good oxidizing agent. For so much so, hydrogen plus ion, proton H plus ion can accept electron to form H. So H plus ion is a very good oxidizing agent. H plus ion is a very good oxidizing agent. Concerned sulfuric acid, concerned nitric acid, they have a strong tendency to donate H plus ion. Hence, the other way we can say that they are donating H plus ion, that H plus ion is bringing out oxidation. Hence, we say that H plus ion is a very good oxidizing agent. So question may come to you, hydrogen is a nascent hydrogen is a reducing agent, but H plus ion is an oxidizing agent. Question may come to you, this is the way you can explain this. So this is a H plus is an oxidizing agent. So these are the substances similar. There are those substances which are electron deficient, those molecules which are electron deficient, they are also very good oxidizing agents. So who are the ferrichloride? Ferrichloride is also used in oxidizing agent. So ferrichloride can be an oxidizing agent. Why? Because it is an electron deficient molecule. It can accept electron. It can easily accept electron. So these substances which are electron deficient molecules, so we can say that all electron deficient molecules are good oxidizing agents. All electron deficient molecules. So electron deficient molecules are called as Lewis acids. All electron deficient molecules are called as Lewis acid. They are called as Lewis acid. So all Lewis acids are oxidizing agents. All electron deficient molecules are called Lewis acids. So Lewis acids are very good oxidizing agent. So if you understand one word, that what is oxidation is a loss of electron. Who carries out oxidation? Oxidizing agent carries out oxidation. So the electron lost will be accepted by oxidizing agent. Substances capable of have a strong tendency to accept electron are very good oxidizing agents. So in this way we can classify the substances in oxidizing agent. So next class we will discuss what is reducing agent, and then we will go to write what is redox reaction and how to what is redox reaction and how to write a redox reactions and how to balance redox reactions we will discuss. Thank you very much, children. We will start next class what is reducing agent and what is redox reaction.